Okay, and these problems are supposed to determine which ordered pair are a solution to the inequality. And the best way to do this is just to simply graph the inequality. And so that's what we're going to do with this one. So best to graph inequality. Now remember, to graph inequality or a linear equation, what we want to do is we want to make a table. Let's go ahead and make us a t-table where we have a column of x's and a column of y values. Now our first x is always 0, and our other two x's will be based upon the denominator. We choose a positive 3, and then we choose a negative 3. Now we'll go ahead and put those in a calculator. You can see I've already got them in there. I have the first one, a negative 2 divided by 3 times 0 plus 2 will give me a positive 2. We'll look at the next one. I have negative 2 divided by 3 times 3 plus 2 will give me 0. And the last one, I have a negative 2 divided by 3 times a negative 3 will give me 4. Now what we want to do is plot those values on our graph. So plot the table. Now be careful that you've got to make sure that you plot your values correctly so you get the right line. 0 and 2, I have 3 on the x, 0 on the y, so I go 3 on the x and go and stay at 0 on the y. Negative 3, I'll go over negative 3 and then up 4. Now remember, the inequality that I have is a less than. So that means it's a dotted line. There's no equal to bar underneath it. So if it did have an equal to bar, then I would have a solid line. So that's the difference. Now what the equal to means is that any point that's on that dotted line cannot be part of the solution. I also have a less than, so less than I shade downward. That means I shade below whatever line I have. Okay, let's get out a ruler and line it up on our 3 points that we have and see what line we get. Let me set this thing up. There we go. I'll go ahead and draw my dotted line. Now I think on this problem we don't have any that lie on the line. I think all of them are somewhere else. So just remember, if there's any on the line, because the line's dotted, points on the line don't count. So points cannot be on the line for us to use them. All right, let's go ahead and graph letter A. We'll be graphing A, B, C, and D. A is a negative 4 and up 2. Oh, let's go ahead and shade my area first. I haven't done that yet. Here we go. Let's do this first. So any point that's found in this shaded area, doesn't matter which one I choose, any point in here will make that inequality read true. And so again, the ones that I am going to be testing are A, B, C, and D. So here's my shaded area. So anything in there will work. Okay, let's graph a negative 4 and 2 is right there. That's letter A. It is in the shaded area, so it works. Now let's look at B. B's at 2 and 6, so 2 on the x, 6 on the y. That doesn't work, so I'm going to cross that one out. C is at a negative 3 and 0. That's in the shaded area, so that one works. And then D is at 0, negative 4, and that works. So those are the 3 points that work. So there we go. And thank you for watching. This is another problem where we're graphing an inequality. This is a little bit different, but it's about the same. We're going to first start by making a table. Now our values here will depend upon the denominator, but we can see there is no denominator. That means we'll have to use a 1. Our first x will always be 0. Then we look at the denominator to get the other x's. So I'll use 1 and a negative 1. Now we'll go ahead and put my values in the calculator. I choose 0 for my first x. It gives me a negative 2. 1 I put into the equation. It gives me a negative 5. And then if I plug in negative 1 into that equation, I get a positive 1. Now I want to graph those points from the table onto my coordinate plane. 0, negative 2, I go over halfway between 0 and 1, and halfway between a negative 4 and 6 will be the negative 5. Negative 1 will be right there, negative 1 and 1. Now my inequality, if you look at my inequality, it has an equal to bar, so that means it will be a solid line, so any point that lies on the line can be included. And then I also shade above because it's greater than, and we know that greater than points upward. Now let's go ahead and draw my line. Take out a ruler or a straight edge. Line it up on your ordered pair, and we want to go ahead and graph the line. Now we're ready to do the shading. Remember, the shading shades above the line, so I shade right there. And let's go ahead and do my shading. I'm just going to make some straight lines along that area. Now remember, for an ordered pair to be a solution, it has to lie in this shaded area. Any point will work that lies in there. Now we want to go ahead and plot the points A, B, C, and D. And any point that lies on the line or in the shaded area will be a yes. Okay, let's graph a negative 4 and 2. There's a negative 4 and 2. It's outside the shaded area, so that is a no. 2 and 6 is in the shaded area, so it is a yes. Negative 3 on the x and 0 on the y, that's a no. And 0 and a negative 4 down right there, that is also a no. So the only solution to this one will be point B. All right, there we go, and thanks for watching. So now in this problem, because it's in standard form, you do not want to graph it. In standard form is where it looks like ax plus by equals c, and you can see that we have that right at the left right there where the arrow is. And so what we want to do is test each ordered pair. You can see that I plugged it into the calculator and I have the values that the right hand side equals. So if you look at A says the negative 10 is greater than a negative 2, and negative 10 is not greater than a negative 2, so that means it's false. It doesn't work. Now I'll go back to my calculator. You can see I've plugged in 2 and 6, which is point B. It's 12. 12 is greater than or equal to a negative 2, so that's also true, or that's true. And then if I look at C equals a negative 9. Negative 9 is not greater or equal to a negative 2, so that's false. And now I'll check the last point using my calculator. So let me bring it back up again. You can see where I plugged it in, and it says that negative 4 is greater than or equal to a negative 2, so that's false as well. So the only one that's true is B. So that means B, out of those 4 answers, B is the only one that works. And so out of my choices, that's the one that applies.